In this video, we will solve the question is asked in Indian Economic Service paper of 2025 of General Economics paper. The question is construct the compensated demand function from one utility function. We have the utility is a function of two goods Q1 and Q2 which are related like this: Q1 raised power alpha times Q2. Explain the shape of this demand curve. What would be the optimum expenditure function in this problem? Okay, so since we have to construct the compensated demand function, that means we need to find out the Hixian demand function. Compensated demand function represents the quantity of a good a consumer would purchase at different prices if they were compensated for any change in their real income or utility due to the change in the prices. So endeavor is our we want to minimize the expenditure. What will be the expenditure? That is price of good 1 times units of good 1 plus price of good 2 times units of good 2, subject to the fixed level of utility that the consumer wants to achieve. So that is equal to Q1 raised power alpha times Q2, which is our utility function, and we want to achieve a fixed level of utility. I have drawn this indifference curve here. So with the given utility level, we want to minimize the expenditure. Okay, so first we need to find out the compensated demand function here for good x1 and good x2. Okay, for that we know that optimality occurs where the indifference curve and budget constraint or expenditure function are tangent to each other. So the condition for optimum is that we need to marginal rate of substitution between two goods Q1 and Q2 should be equal to the ratio of the prices, that is P1 upon P2. Okay, now we know that MRS is simply equal to, it is the ratio of the marginal utility of good 1 upon marginal utility of good 2. It should be equal to the ratio of price P1 upon P2. Marginal utility, as we know, it is simply the change in the total utility due to the consumption of good Q1, and MU2 means the change in the total utility due to the consumption of good 2. It should be equal to the ratio of the prices. We need to find out the compensated demand function first, which implies, so du upon d, let's write here dq1 and here dq2. So dq1 upon du upon dq1 means the partial derivative of this utility function with respect to q1. So derivative of q1 by power function rule is we get alpha q1 raised power alpha minus 1 times q2 divided by, I hope it is visible to you, upon the derivative of this function with respect to q1, that is with respect to q2. Derivative of q2 is 1, so we are left with q1 raised power alpha only, and it should be equal to the ratio of the prices p1 upon p2. Okay, now if we rewrite this function, so this can be written like this. So we have alpha times q2 divided by, we have q1 raised power alpha, transpose this term here, it becomes q1 raised power minus alpha plus 1. Okay, I have transposed this term to denominator, its exponent sign will change. Alpha is here plus, it becomes minus, so we have negative 1, it becomes plus, and it should be equal to the ratio of the prices P1 upon P2. So what will we get? Which implies, or let me write it here. So we have alpha Q2 divided by, since we have the same basis, we can add up the exponent. So we alpha minus alpha is 0 plus 1, so we get Q1 only in the denominator, and it should be equal to the ratio of the prices P1 upon P2. Now can we write Q1 times P1, cross multiplying Q1 times P1 is equal to alpha Q2 into P2. Okay, so dividing both sides by P1, that means Q1 will be equal to, so we have alpha P2 upon P1 times Q2. Okay, now what we do, we plug this value of Q1 into this utility constraint function. That means in place of Q1 we have this function, that is alpha p2 divided by p1 times q2 raised power alpha times q2 should be equal to utility level, which is fixed here as u naught. Rewriting this, so can we rewrite it like this: alpha p2 upon p1 raised power alpha times, expanding this, so we get q2 raised power alpha times q2 is equal to u naught. Okay, so let me see if I am within the boundaries. Now we have here q2 raised power alpha times q2 raised power 1, so we will get, so let me write it here. I get here q2 raised power 1 plus alpha will be equal to, so we have here u naught, transpose this term here, it becomes alpha p2 divided by p1 raised power alpha here. Okay, or q2 will be equal to, so q2 is equal to, transpose this exponent here, so we will get u naught upon alpha p2 upon p1 raised power alpha whole raised power, what we call, if I transpose 1 upon alpha, it becomes 1 divided by 1 plus alpha. This is the demand function for good q2. And what is actually it? In Hixian demand, demand of a good is a function of the prices and the utility, unlike in case of the uncompensated demand function, where demand of a good was a function of what we call the income and the prices. Okay, so we got a demand function for good q2. Likewise, we need to find out the demand function for good q1. So we plug q2 is this stuff into demand function in this demand function. That means q1 will be equal to, so we have alpha p2 upon p1 okay times the value of q2. Q2 is this very function. We have u naught divided by alpha p2 upon p1 whole raised power alpha and whole raising it to the 1 upon 1 plus alpha. Okay, solving further, so can we rewrite it like this: q1 is equal to, so let's expand it, so we get here u naught raised power 1 divided by 1 plus alpha divided by, here we have alpha p2 upon p1 raised power alpha whole raised power 1 upon 1 plus alpha, and then we have this term. Okay, if I transpose it to the denominator, what happens? So since its power is 1, and if I transpose it to the denominator, it will become alpha p2 upon p1 raised power negative 1. Okay, that means q1 will be equal to u naught raised power 1 divided by 1 plus alpha divided by, we get here alpha p2 upon p1, so we have alpha times this, so we get alpha divided by 1 plus alpha, this is the exponent here, times this exponent, that is alpha p2 upon p1 raised power minus alpha. Having said that, that means q1 will be equal to, or q1 is equal to, we have u naught raised power 1 divided by 1 plus alpha divided by, here we have the same basis and we can add the exponents, so we will get alpha p2 divided by Okay, so we have alpha p2 divided by p1 whole raised power alpha divided by 1 minus alpha. Then we have negative 1. Since bases are same, we can subtract the exponents here. So here we have alpha, doing cross multiplication, we will get minus 1 plus alpha. That means this gets, so we get here alpha minus 1 plus alpha. Rather, we have 1 plus alpha here, so we get alpha minus 1 and minus alpha. So we get, or let me rewrite it here. So we have u naught raised power 1 divided by 1 plus alpha divided by alpha p2 upon p1. So this will become here alpha minus 1 minus alpha divided by 1 plus alpha. So this gets cancelled. We get here minus 1 divided by 1 plus alpha. Okay, since we have the same, we are just subtracting the exponent here, and it will come out this very thing. That means demand function for good q1 will be equal to, we have u naught raised power 1 divided by 1 plus alpha divided by, so since we have the negative exponent here, to make it positive we reciprocate the terms in the braces. So can we write p1 divided by alpha p2 raised power, so the exponent will become positive 1 divided by 1 plus alpha, or we will get u naught we will get u naught divided by p1 upon alpha p2, okay, whole raised power 1 divided by 1 plus alpha. Okay, and this is these are the demand functions for good q1 and q2 here. So this is q2, this is our q1. Now we are also being told what would be the optimum expenditure function in this problem. So to find out the expenditure function, what we do, we plug the compensated demand functions, that is q1 and q2, into the expenditure function. That means our optimum expenditure function will be equal to, so we have p1 times q1 that we got here, which is equal to u naught divided by alpha p2 upon p1 raised power alpha whole raised power 1 divided by 1 plus alpha. Then we have plus p2 times q1. q1 is this u naught divided by p1 divided by alpha p2 whole raised power 1 divided by 1 plus alpha. Okay, so we can also further simplify it. So this will be our expenditure function in this case. Okay, so I hope I make myself clear in this video. So what exactly are the action demand functions? Compensated demand function. So you can see compensated demand function is a function, or compensated demand function for a good is a function of utility and prices, unlike the uncompensated demand.